This time, we're going to discuss the conditional statements in C programming language. Now, we have already discussed the execution flow of these conditional statements when we discuss flowchart. We have three conditional statements. The first one is called if statement. The if statement is called one-way branching statement because if the condition is true, this one here, then the program will have this action block executed. When the condition is false, then the program will not do anything. Okay, so this code will only do an action or set of actions or instructions if the condition is true. If it is false, then it doesn't do anything. Okay, nothing is done when it is false. That's why it is called a one-way branching statement. It do an action when the condition is true. Do nothing when the condition is false. So this is the syntax. The condition is enclosed in parentheses, and we call this one the action block. And this could be a single statement, only one statement or instructions, or this could be a compound statement. What is a compound statement? A compound statement is a set of zero or more. So take note, it could be empty, zero or more statements or instructions to be executed. Like for example, if you say, if x is greater 0, then there is only a single statement to be executed. You say x is positive. Okay, that's the only action. So this is a single statement. Now we could also say if x is greater 0, then instead of just a single statement, you could have a compound statement. So we call this now a compound statement. A compound statement is marked by the open as the beginning marker and the close curly. The open curly marks the beginning of the block and the close curly marks the end of the block. So this encloses this set of zero or more statements. So say for example, we would execute printf x is positive. Then after that, we will have another statement, x gets x plus 1. We add 1 to x. Okay? So since there are two statements, the action block consists of two statements to be executed. We call this now a compound statement. And since there are two, they need to be enclosed by curly braces. So this is again an example of a compound statement. That is a compound statement enclosed by curly braces because there are more than one. If there is only one statement in the action block, then you don't need to enclose it with curly braces, but you may do so. Okay, so you can still enclose that one statement inside curly braces if you want, but it is not necessary. The curly braces are necessary only if there are more than one statements in the action block. The second conditional statement is called the if-else statement. So this is also called a two-way branching statement. Two-way because we have here only one condition. If the condition is evaluated to be true, then the program has action block 1 to execute. And this is not executed. But if the condition is false, this action block 1 is not executed. The else block, say we call this the action block 2, the else block is executed. So that is why it is called two-way, because the program will do action 1, and this could be a single statement, or this could be a compound statement. It will do action 1 if the condition is true. Okay, and if it is false, it will do another action block 2. So there are two ways. If the condition is true, it do or perform this action block. If it is false, it would execute this one. So only one of these two action blocks are executed. If the condition is true, this is executed and this one is not. If it is false, this one is not executed. This is the one that is executed. So that is the meaning of the if-else statement. So again, if the condition is true, this block here is executed and this one is not. If the condition is false, this is not executed, this is executed. The third one is called Ladderized if-else, or we call this multi-way decision, because there could be more than two actions to be performed or to be executed. Okay, so this is one action block, action 1, and this is action block 2. This is the third option, and say this is the action n. Say there are n possible action blocks. So again, we call it multi-way or ladderized if-else if there are more than two action blocks. Okay, so 3 or more, that is now a ladderized if-else or multi-way action. And take note that for every action block, there is before it a condition to be satisfied. So we have here condition 1, and then we have here condition 2, condition 3. Now, say we have 3 conditions. Say we have here if, this is condition 1, then you do this set of statements. We call this the action 1. And then we say else if, condition 2, and then we have another compound statement. This is our action 2. And then we say here else if, condition 3, and then you have another compound statement, and we call this the action 3. Say, for example, this is the statement here. Now, there are 3 possible actions to perform: action 1, action 2, and action 3. And there are also 3 conditions. Now, the action of the 3 action blocks, 1, 2, or 3, there is only one action block that will be executed. Again, there is only one action block that will be executed at any given moment. So, which action block is executed? It is the one whose condition is true. Say, for example, when the program evaluates condition 1 and it is found to be true, then this set of statements here, or action block 1, will be executed, and all the other action blocks are not executed. So this is the only one executed. All the rest of the action blocks are not. But if this is false, then this action block number 1 is not executed. Okay, not executed. The program will proceed to check condition 2. If condition 2 is true, then this action block 2 will be executed, all the statements inside, and the next action blocks will not be executed. So take note, only one at a moment, whichever condition is true. Now, what if this is false? So this is not executed, and this is found to be false also. So this is not executed. the program will evaluate condition 3 because there is a condition here. So when this is found to be true, then this third action block will be executed. All the statements inside will be executed if this condition 3 here is true. Now, what if all the conditions, the three conditions, are false? So this is false, condition 1. So action block 1 is not executed. And then condition 2 is also false, and therefore action block 2 is not executed. And then condition 3 is also false, and therefore action block 3 is also not executed. So when all the conditions are false, then all the action blocks are not executed. None of the action blocks are executed. But in this case, okay, look at our example. Say the action block number 3 has no condition. So meaning there are only two conditions. Condition 1 for action 1, condition 2 for action 2, and for action 3 there is no condition. Okay, so there is no if condition here. So in that case, if this is found to be false, so this is not executed. If that second condition is false, so this is not executed. Automatically, action 3 or action block 3, this compound statement here will be executed. All the statements inside the compound statement will be automatically executed since all the above conditions are false, and this action here has no condition to be satisfied. Okay, so automatic. This is equivalent to the word otherwise. Okay, if none of the conditions above are true, then automatically action 3 is executed without satisfying any condition because there is no condition that is placed in here. Now let's have an example for number 3, the ladderized if-else or the multi-way decision. Say for example, we're going to create a program that asks users to input an integer x. Say for example, we have this void main, and then we declare x as an integer type, and then we ask the user to input the value for x, and then we determine if it is positive, negative, or 0. So you could say if x is greater 0, then we say %d is positive. And then we output for this conversion specification %d, we output the value of x. And then we say else if x is less than 0, then we output that x is negative. And for that conversion specification, we output the value of x. And then we say else, automatically we would, if it's not positive and negative, we would say %d is 0. And then we output the value of x. Okay, so this is an example of number 3, ladderized if-else or multi-way decision. So this is our condition 1. Say for example, we input here the value of x input by the user is 5. So this is true. 5 greater 0 is true. So this is executed and all the rest are not. But if the input is negative 5, this is false. And so that is not executed. The output is what? After that, since that is false and this is not executed, the program will check that condition. Negative 5 is less than 0. That's true. Therefore, this second action block, else if block, is executed and this is not. So not executed, executed, not executed. But if the user inputs 0 for value of x, then this is false, and so this is not executed. This is also false, and so this is not executed. And automatically, this last printf here is executed. No need for you to say if x is equal to 0. Okay? Again, there is no need to put this condition because if x is not greater 0 and not less than 0, then in the number line, remember, if that is 0 and this is positive 1 and this is negative 1, if x is not this, not here, not belonging to that, and not belonging to that, then your x is 0 because there is no other value left in the set of integers. Another example for number 3 is, say for example, we are computing a grade of the student. Say grade is equal to score divided by total. Okay, so the score obtained by the student in the exam over the total points times 100. Okay, so that is how grade is computed. And we then let the program determine the remark for the grade. So say the grade is from 95 to 100. We want it to display that the grade of the student is excellent. And if it is 90 to 94, it is very good. If it is 89, so that's 89, 85 to 89, we would output good. If it is 80 to 84, we would want to output fair. If it is 75 to 79, we would say pass. And if it is below, if it is 74 below, 74 and below, we will output fail. So we would say here, say we declare grade as integer. So this would be giving us an integer value which is then assigned to grade. And then we say for this, what conditions should we write here so that when that is true, we would output grade is excellent. Else, if this condition, we would output grade is very good. And then we say else if another condition for the good, we would say grade is good. And then another condition for fair, then we output printf grade is fair. And then we say else if another condition, and then we output grade is passed. And lastly, we would say else if, and then output printf grade is failed. So what should be the condition here? The condition here, the condition here, the condition here, in here, and here. It is excellent if grade is, the value of grade is 95 to 100. How do we write that in the syntax of C? Say this is 95, and then this is 100, this is 90, this is 85. So this one, the range here is represented by this range here, right? So you have a solid circle to mean that 95 is included and also 100. Okay, in this case, 90 to 94, this would be solid and this would be open, right? Because 95 is not included. It's only 94 here. So how do you write this range of values in the syntax of C, in C programming language syntax? Okay, take note that these values here, from that to that, we denote it as grade greater or equal to 95, right? While this one here, from 100 below, that is grade is less than or equal to 100, right? So this set here, range of values, is represented by that expression, and from 95 above is represented by grade greater or equal to 95. But we are only looking at these values. So it is the intersection of this one and this one. What is the logical operator equivalent for intersection? Remember, the logical operators are, this is the AND, this is the OR, and this is the NOT. The intersection is represented by the AND. Union is OR. So we're going to use AND. So we say here, grade greater or equal to 95 and grade less than or equal to 100. And so this one, which is 90 to 94, would be grade greater or equal 90 and grade less than or equal to 94. And then this is grade greater or equal to, okay, we are now on the third range, 85, and grade is less than or equal 89. And then next, this would be this one, 80 to 84. So we say here grade greater or equal to 80 and grade less than or equal to 84. And then the next is this one, if grade is greater or equal to 75 and grade is less than or equal to 79. And lastly, for the fail below 74, we would say if grade is less than or equal to 74, then the output is that grade is failed. Now, why do we put here a condition? Why not just say else, no condition, and then direct to printf? After the else, then the printf, there is no condition. If there is no condition here, then if grade is above 100, this will be executed because this is equivalent to otherwise. If it's not within this range, not within this range, not within this range, not within this range, not within this range. So what are the values not within this range? It would be 74 below and above 100, right? Including above 100. It falls to this else, the last else. Okay, because what if the value of grade is 105 because the student were able to answer the bonus points, and so instead of 100 perfect score, he obtained or she obtained 105. And so it's not excellent because the excellent grade is only until 100, and so it falls in the else block. That's why, to avoid that to happen, we need to specify the condition for a failing grade. And that condition for failing grade is grade less than or equal to 74. If you want to capture the above 100, so that if it is more than 100, the value of grade, then it would output excellent. Then we will change this one to what? We will change this to what should be the new condition. It should be grade greater or equal to 95. So from 95 above, beyond 100, above 100, it is excellent. So the lowest value for grade that is excellent is 95.